Hi, I'm Margaret. In this video I'm going to introduce you to enum types. An enum or enum type is a special class that defines a set of constants. Variables of the type must be equal to one of the constant values that have been predefined. Let's look at an example. Here I have an enum called direction. The predefined choices are north, south, east, or west. Notice the keyword enum and the curly braces. Also notice how similar an enum declaration is to a class declaration. This shouldn't be too surprising because an enum is a class. So we have an access modifier, a keyword, usually class. In the special case of an enum class, we just call it enum. We have a name, for example, triangle for my class or direction for my enum. We have curly braces to delimit the class body. And we have something in between. So here in a class you typically see fields, constructors, methods. All of that could also be part of my enum, but only after my enum constants have been declared. Every enum starts with the declaration of enum constants. I also want to point out that my enum constants are separated by commas. So you can see that right here. Now let's have a look at how to use enums. I'll give you a different example. Here I have season with the choices spring, summer, fall, and winter. And in my main method I could declare a local variable called favorite season. It is of type season, and I'm assigning one of my seasons, in this case spring. So I say season.spring. Works great because spring is one of my predefined choices. Also, notice the similarity to math.py. When I'm accessing the static final field pi of class math, I take my type, dot operator, and constant name. Here I have type, dot operator, constant name. If I would try to access autumn, I would get a compile time error because autumn was not one of my predefined choices. The moment I want to assign a value to a variable of type season, it has to be one of my limited predefined constant choices. By the way, all those choices have to be uniquely different, no doubles there. Let's look at the differences and similarities between enums and quote-unquote regular classes. So here I still have my enum season, and I'm defining a class that is very similar. I call it season 2. Now here I use the keyword class because it's a quote-unquote regular class, and I don't have enum constants because this is not an enum, it's just a class, but I can create 4 fields. And I can name them spring, summer, fall, and winter. Notice that each of my fields has a value assigned, 0, 1, 2, 3. Each of your enum constants also has a corresponding numeric value. So here spring would have the value 0, summer 1, fall 2, winter 3. Notice how we use all uppercase letters when we declare our constant names. The reason is Java has a naming conventions. Constants in Java are spelled in all uppercase letters. Now here, in the case of my class season 2, each of my fields is declared final. Very easy to see this is a constant because it's declared final. Notice, spring in my enum does not have a final keyword, but it is final because enum constants are implicitly final. Also notice that each of my constants in season 2 is declared static. There's no static keyword, but it is static. This is the reason why we were calling it on the type with season.spring, just like math.by. It is static because enum constants are implicitly static. So enum constants are implicitly both static and final. Why do we use enums? There are two good reasons. They're easy to read and the compiler can catch errors. Let's just look at the alternative. I could create, for example, a variable season A as an integer because I know it has an underlying int value. And I could say, well, season A is 3. That's not easy to read. If I compare somewhere in my code, is season A 1? Then I have to remind myself, was one spring, was one summer? So not very intuitive, not easy to read. Also, if I make a typo and I press my 3 twice, I would say season A is 33. Compiler would not be able to help me out. It would just accept 33 as a perfectly legitimate integer value. What would happen if I would say, well, my season variable is declared as a string. So I have season B declared as a string. I call it summer. So advantage here, this is more intuitive, easier to read. If I say summer, I know what I'm talking about. On the downside, I still don't have the support from the compiler to help me find typos. If I spell summer with one M, the compiler won't warn me. Yet another possibility. I could use season 1, my quote-unquote regular class, with my static final fields and access summer on season 1. Now in this case, this is easy to read because I'm saying summer right here, which makes it very clear what season I have in mind. Also, the compiler can catch my errors. If I would spell summer with a single M, the compiler would realize there is no field declared with one M, and I would get a compile time error. I'm not perfectly happy though at this point because season C is of type int, and really this is representing a season and not a number. So there is a disconnect between what I am representing and the type I use. The fourth possibility, and you can see everything is starting to brighten up on this side, is the use of my enum. Here I declare my season D as a season. Season D is a season. That is appropriate. That's what I try to convey. That's what I try to represent. Here I refer to summer by season.summer. This is intuitive. This is easy to read, so I get a nice check here. Also, my compiler can catch errors. If I would spell summer with a single M, the compiler would notice because there is no enum constant declared with a single M. So this is the preferred way to go when we have a limited amount of choices. Which takes us to the next question: when should we use enumerations? Different way to say enums or enum types. We use them when we need to represent a fixed set of constants. I showed you a couple examples already, but here are some more. For example, the days of the week. For example, directions like up, down, left, right. For example, the rank of a card or the suit of a card. All those situations have a predefined limited amount of possible values. And the last thing I want to show you is a static method that is available to all enums. It is called values. Values will give me an array with all my different enum constant values. Here, one last example. Let's say I have an enum, direction, up, down, left, right, and I want to print all my different choices. I could have a for each loop. I say for each direction element in my direction values. So direction values is this array that contains all my different choices, and then I'm just printing them out one at a time.